Hey everybody, this is Dr. Ben Pearl with FitFootU. Today we have a special segment. We're going to be talking shoe fit, shoe options. We're going to have some fun going over some metrics with shoes and talk a little bit about some shoe metrics with injuries. First thing, the most important thing, and since this is called FitFootU, we're going to be talking about shoe fit. Most of us buy our shoes too tight, whether it be a dress shoe or a running shoe. What I like to think of this when we use the fitting devices, I like to think of why not use a Brannick device like we measure the length of the foot for the internal fit of the shoe. So this is something that my colleague Golden Harper, who's designed one of the zero drop shoes, came up with. He said, why not use one of these correct toes as a shoe fit device? What do we mean by that? Well, let's take a look at the typical shoe insert. If we have our foot in here and it is too tight, when we put this shoe fit device between these correct toes, it will expand out the toes. What's the purpose of that? Because we want to have room for circulation, room for swelling in the foot, and particularly if we start having deformities, injuries that affect the toes, we don't want the toes to be squashed up. So this becomes a perfect device to fit form to the shoe, form being the foot. Okay, now once we have a properly fitted shoe, what are our options in terms of stack height, and what does stack height mean? Well, I'm going to give an example of a brand called Topo where we're going to go with first a 28 millimeter stack height. And you can see this is the EVA, the expandable material that will compress, and that will give you your ride on the shoe. Now, it is important to recognize that just because something has more stack height does not mean that it's going to reduce the injuries. In fact, there's been nothing corroborated to show that more stack height and more cushioning will lead to better prevention of injury. What we do know, though, however, is let's say I'm recovering from a stress fracture and I have a really skinny mini 4 millimeter stack height. That might be a problem because now you have virtually nothing between you, the foot, and the ground except 4 millimeters. And that's going to be so flexy that that might be too much for your foot to handle at that particular point. Same might adhere to something where we have too much tension through the plantar fascia, which runs from the heel to the forefoot. Again, if we have a stack height that it is a little more thick, and once you get to a certain degree, it's sort of preference, personal preference and ride. Now, let's jump up to a 33. You see it's a little bit thicker. Then we can go all the way to 35. We're adding weight, by the way, with each one of these iterations, okay? But now we have what turns out to be something very, very hard to flex. And what is the purpose of this? Well, it's going to flex when we're running, of course, because we have to toe off. But the advantage of this for someone like me, for instance, where I've bashed up my first metatarsal and have a turf toe right at this joint capsule area between the first metatarsal joint, is that when my toe is propulsing, instead of having something real flimsy, I now have something nice and stable. And even if it has a little arc at the end, a little rocker of sorts in the forefoot, that can also make a better ride for somebody like me. Now, we're going to talk about variations in terms of differential between the heel drop. Everybody talks about what's a zero drop, what's a zero drop? Well, we know that a zero drop has no distance differentiation between the forefoot and the heel. This is an example of an Ultra shoe. This is an Ultra Paradigm. Now I'm going to show you the same concept with the Topo shoe, another zero drop shoe. What's the advantage of a shoe like this with a nice wide forefoot? Well, I'll tell you. If you have a shoe that has a wide forefoot and a zero drop, and I have an aroma, I'd rather be stacked over the ankle, over this joint right here, than having that ride and pressure on my forefoot. So that's integral to helping heal some of the common forefoot injuries that we see in a sports medicine podiatry office. They might be a neuroma. It might be a recovering stress fracture. It might be a capsulitis of the second metatarsal. It could be all those things. It could be just aching in the metatarsal heads without being a fracture. So there's all kinds of conditions where it might be a little bit better to be a little bit more stacked over the ankle and not quite as high on the forefoot. Now, most commercial running shoes, let's say a Nike, are going to somewhere ride between 12 and 14 on the heel stack height differential. Now we can go up baby steps. This is an example now of going up baby steps where we only have 3 millimeter rise, okay? 3 millimeter rise on this. So why is that important? Well, a 3 or even a 5 millimeter rise, as I have in this shoe, and these are all 5 millimeter rises, just different stack heights. The advantage of doing a 3 or 5, if you've never worn a zero drop shoe, is that now you are not putting too much tension, and here's the chalk talk portion of this, on the Achilles tendon, which is going to insert right here in the back of the heel. So if we have a little bit of a rise, we take some tension off the Achilles tendon. And we also can take a little bit of pressure sometimes off the plantar fascia. Why? Because if we have a little bit of a rise and this structure isn't quite as tight, the Achilles tendon, some of these fibers will cross over from the Achilles to the plantar fascia. So that's one of the advantages of not going all the way too fast to a zero drop. Sometimes it takes a little bit of habituation, a little bit of running before you get the feel for how that ride is going to be, and having some motor mapping internally with your body so your body can get used to it. Now, one of the things that I like to do is I don't like to ride the same stack heights every time I run. I like some variability. So variability with terrain, undulating terrain, maybe not always hills, maybe not always flats, maybe not always banked turns, maybe not always turning to the right in the same counterclockwise direction or clockwise direction. And finally, we can affect the variability with the ride of the shoe, as I mentioned, with the heel drop. So you can go from 0 to 5 to 7, etc. Now, we're going to, in the home stretch here, stay with me. One of the things that we need to appreciate is that forces have different moment arms or different torques at different portions of where the force is directed. So let's say, for example, I've drawn this little model and we're applying force here to the forefoot. Let's say we have ground reactive force at about 700 newtons. Let's say the distance here between the first metatarsal right here and over here to the ankle is approximately 10 centimeters. So we end up with about 700 Newton centimeters or Newton meters as the total force. Now here's the tricky part. If we go closer into the ankle, not as much distance, so the force is not as much. Here we have a longer lever arm, so force directed in the forefoot is going to be an increased force. Over here, we only have about 5 centimeters from the Achilles tendon to the center of the ankle, so less directed force on the lever arm, which means you would have to have a higher force to get the same 700 Newton meters of force. Now, just to make the equation even a little bit more complicated, we're talking now external forces and internal forces. Let's just remember that regardless of what the force is externally from ground reaction, the internal forces on joints are very different than the ground reactive force because there's a lot of moving parts. You have your hip moving, you have your knee moving, you have flexion, you have extension. Now let's add one more element. Not only do you have the hinge ankle joint, but you have the universal subtalar joint right here. So now we've added yet another layer of complexity. The foot has 26 bones. It's a very complex, very marvelous structure, but you can't take an argument that because we have ground reactive force X, that it's going to be the same effect on every individual. Running is very individualistic. We know that. Listen, I hope you've got some good tips. Please put some comments on if you have any questions about this video. Until next time, this is Dr. Ben Pearl with FitFoot U.